Yes, good evening, everyone. Welcome to today's class. So we kickstart the class while others join. So today we'll be having my colleague Justus that will be handling the class. So Justus, you have the floor.
Thank you, Lamdi. Hi, good evening, everyone. I hope you're all having a very good weekend. Can you please confirm that you can hear me?
Yes, can hear you.
Okay, perfect.
Yes.
Thank you. So, good evening. So today I'll be covering the day 4 of the SQL class. I know we've covered a couple of things like the introduction, select, where, order by, and group by, and we're going to continue from where Olamide stopped last week. Let me share my screen quickly. Okay. Okay. Can you all see my screen?
Yes.
Okay, perfect. All right. So before I start, let me know if you have any questions. Feel free to stop me at any point in time, or just raise up your hand or the chat section if you have any questions, or if I'm going too fast. Please let me know. So today we'll be covering subqueries in SQL, and I'll say this is a very important topic because a lot of times when you work with your data, you would need to have written, you need to write, most times or a lot of times, you need to write a subquery to get your final answer. And basically, a subquery is basically saying you are selecting or you are getting data from already queried data. So you've written an SQL statement already, and you now want to get new insights from this already queried data. Of course, you know that when you have your data sets, it's not clean and it's messy, it's not well structured. So there are times that in order to arrive at your final answer, you need to write a subquery to get new information from the already gotten information from the original data. And so we'll be covering subqueries first, and then we're also going to touch on date functions. We'll cover date functions. We'll cover string functions, and then we'll cover date functions, string functions, and then case when statements, how to group things together as one. Before I proceed, I wanted to talk about understanding the data. Before you begin your data analytics process, it's important for you to understand the kind of data that you're dealing with. So for instance, when I had this data, right, when I was given this data set, first thing I did was to come to this metadata, right, to see, okay, what information do we have? Try to understand the data set. So a metadata is like data of the data, right? You want to understand this data set that I have, what columns do I have in this data set, and what do they even mean? Because understanding the data that you have will actually help you to come up with better analysis, right? And it helps you understand how you are going to structure that data, or how best you should structure that data. So, that was the first thing I did. Airport codes, try to understand what this means. The columns there, the flight table, understand what columns we have, and then the ticket table, understand what columns we have. Also, this metadata, also called like a data dictionary, it kind of informs how you are also going to structure, or informs what kind of data types you would be using for your data sets. And I mean, when it comes to SQL and other programming languages, data types are very important. Basically, it talks about what format your particular data is in, or what format your particular column is in. So, um, and with the wrong data type, your analysis can just go wrong. So it's important that you take note of, okay, is this an integer, which is just a number, right? For instance, number of people or passengers has to be an integer because you can't have 1.5 person, right? But if you are saying, for instance, distance, you can have 1.5 meters. So there's a difference between an integer and a decimal point, or a decimal in that sense. And then, of course, we have strings, we have dates. So all these data types, I mean, understanding the right data type to use for your analysis, whether this should be a string or this should be a number or a date, is also very important. And after getting this, I mean, so the first thing I did was to actually look at the um this data dictionary, and then I also wanted to understand, okay, what does this data look like? The structure of the data, like how is it formatted? And I mean, just opened the Excel sheet, looked at that. For the flight data sets, I know that was it's very heavy, so I just use I just wrote some Python codes to check what that looks like, the structure of the table. I can just share that briefly here. So basically, this was the flight data set. This is the flight data set that we had. And try to understand, because you know that right now, the way we have imported the flight data set into Microsoft SQL Server has some of these columns all together as one single column, because we use the comma separated value. And so because we use a comma separated value, for instance, it took this as two different columns because there's a comma here, right? Took this as two different columns, and that kind of pushed the other columns into occupancy rate. So trying to understand, like, okay, how is it structured and how do I have it imported so that I'm able to structure it correctly. And of course, we have the coordinates here, which is also like longitude and latitude together. So again, all this is just preliminary studies of understanding what your data looks like and how you should format it. So I'm going to go into basically into subqueries right now. And I've talked about how it's data of a data. Sorry, a query inside a query. One option. So when you're writing subqueries, you can either write a subquery using a select statement or a where statement or a from statement. And I would just I'll just begin. So for this particular session, how we're going to do it is try to answer some questions with the data set, and then use subqueries, date functions, try to answer questions using date functions. So we have the flight data set. I'm just going to select we have the flight data set. So it's going to be I'm not going to put training to here. Okay, so this is our flight data set right now, right? We have dates, we have the operating carrier, the tail number, which is like plate number for the airplane, the number, origin, airport. And so, assuming I wanted to find, let me get the tickets table. So let's look at the tickets table because this is not cleaned yet. So I'll just work with the tickets table first for this session, and then we'll go into the flights table after we've done some string manipulation and some transformations. So we have this table, right? Contains the itinerary ID, the year, the quarter, the origin, and all that details. And so, assuming you wanted to get the itineraries that have fares above average. So we have itinerary fare here, right? I want to say, okay, which of these itineraries is above, which of this itinerary fare is above the average itinerary fare, right? In order to select that, so when I want to write queries, I think about, okay, so I want to select itinerary fare above the average, the average fare price, something like that, right? So when I think about this question, right, first thing that comes to mind is that we are looking for which of these particular values, right, is above the average value. So breaking that down, right, first of all, we need to know the average value. What is the average itinerary fare across these data sets, and then find which ones are greater than that. So when you look at a particular query, right, a particular question, it's important that you are able to break it down, and then breaking it down can help you, breaking it into smaller queries. So in this case, my first step is going to be to find the average itinerary fare in this data set. So let's just say select, I'm going to select maybe the origin, and then let's just say destination. And then I'll select the itinerary ID. So let's select the average fare, sorry. Select average, this itinerary fare from this particular table, right? Okay, so we have an error here. It says operand data type varchar is not valid on average operator. So previously I talked about data types and how they are very important. And so for this one now, we need to cast this data type to become a numerical value. So we can use the cast function here. Cast itinerary fare as a decimal point. And then we need to specify how many decimal points we want to use there. From training.dbu, the tickets. Okay, I'm missing one more bracket there. Nice. All right. So again, I talk about data types. So I mean, always being able to read the errors that you have, and being able to understand where the problem is coming from and how to like work around those problems is also very important. So I'm running this right now, and I mean, this might take a minute. But yeah, we are looking for the average itinerary fare. Now, when we get this average itinerary fare, the next step would be to now select those fares that are above this average. So think about that as this is not going to be your subquery. Now, what that simply means is, now we're running this, right? This is going to give us a particular value. For instance, let's say the average price, assume the average is 500, right? Now, what we now want to do is now select which particular pairs that are above this average. I mean, I'm still running this right now, so let's see the value for that. But assuming this, I can now say select. I'm going to say select the origin. I'll select the itinerary ID. Select the origin. Select destination. And then the fare itself. Once select this from this table, where where the itinerary fare is greater than the average price, 500. Itinerary ID.
The select is not complete.
Sorry?
Select is not complete.
Sorry. Select statement. Thank you. So we have this right now. The query is still running. Sorry, my laptop is not very fast. So, but yeah, we have this right, and so I'm assuming that the average value is 500, right? In this case, I've said where itinerary fare is greater than 500, assuming that this was the average. However, in this particular case, this particular value or this particular 500 will be replaced by the average value. But then we don't want to write a different query, and we don't want to write this query, get the average value, for instance, say 500, and then put 500 here. Because if we do that, that would mean that what if you have new data added to your ticket data set? It means that you have taken the average of the previous data set and now you have new information. But because you hard coded this 500, your query is not dynamic. And so in place of that, what I'm going to now put is this particular subquery that we're putting here. I'm just going to copy and paste it, right? So it's going to be I'm going to make this more readable. Like that. Right. So now this is going to be what our software is going to look like, where we are now comparing, we are trying to find the average, the itinerary price that is greater than the average itinerary fare. Converting data type back out to numeric. Okay, so I think I know what the problem is. So right now we currently have itinerary fare, right? And I mean, when I was looking at this data set, I encountered this challenge. Now, using the cast data type, right? The cast function is actually supposed to convert this variable character column to a decimal column, right? However, um, based on the error we found right now, it just said that there is still some characters in there. It means that this itinerary fare column doesn't contain numbers. Some part of it doesn't contain numbers. And so while looking at that, I'm just going to do something. Select all from this table. Where so as you can see, under this itinerary fare, right, some of these contains like empty strings that are actually throwing out, like making this to throw an error. And so there's another function called trycast that would actually return null values. So it's not going, instead of it to throw an error, it's able to catch all these rows that still have some characters in them, or just like empty strings. And so if I use the try cast here, it shouldn't throw an error with this. Average of this try cast. Oh, sorry, I think I need to cast this too. I'm just gonna copy this. Oh, don't worry. I'm gonna cast this too. Try cast this itinerary fare as decimal. Okay. Let's see. So basically why I'm still saying this error is because right now, this itinerary fare here is still a variable character. So literally everywhere I have itinerary fare, I have to change it to a decimal point, because it feels like in this case I'm comparing a character to a numerical value, which is not possible. And that's why I'm still getting that error. So I'm just going to copy and paste what I have there. So, and let's see. Nice. So right now we have seen what, so these are the itinerary IDs that are above the average value, right? And if I run this, let's see what the average value is. Okay, good. So the average itinerary fare for this data set is 408 maybe dollars, or I don't know, right? And so we've been able to write a subquery here that is able to compare. So like we said, first of all, we're able to break down this particular question and find the average fare using this query. And then after finding the average fare, we now compare this new itinerary fare. I say where itinerary fare is greater than this average value. So in this case, this is the subquery here that we have used, and this is subquery that uses like a where clause. Now let's look at another question. Um, let's look at another question. So we can say what are the destinations or that have the highest so we want to find origin to destination that have the highest fare prices. Or let's say the origin that have, let me see, the top 10 origin with maximum fares. So again, in this case, right, what we want to do is saying, okay, which of these origins have the maximum fares? And so what we're going to do is try to get the maximum fares, and then we would select those maximum fares from the subquery. So first of all, we're going to select origin and then the maximum. So we know that each time we're dealing with fares, we have to use the try cast to convert it so that it doesn't throw an error. As decimal. So that is okay. 2, 3, yeah. It's 4 for them. As maximum fare from the tickets table. I'm sure by now you should know that each time you have an aggregate function in your data set, you need to do a group by because you have maximum. So if it is average, maximum, you always have to do a group by, and you have to group by the categorical variable there or like the dimension column there, which is origin in this case. So it's going to be group by origin. Nice. So now we have this phase, right? We have all these phase. And we can also order by order by order by maximum phase. So we want to see top maximum fare. So let's see. So we run this. So this is still running. Nice. Oh, I'm sorry. I didn't put ascending or descending, so I didn't even know what to do right now. I think this is descending order. Sorry, ascending order from smallest to highest. I want us to do descending. Um, I wanted to do descending, but anyways, now if you want to select, for instance, the top 10, so I'm going to put the descending value here, descending. If I was supposed to select the top 10 from here, I can't just put like top 10 here. So I have to kind of write a subquery that will now say select top 10 um, of origin and the maximum fare from what? So we have selected all the maximum fares right now for this particular in this data set, and we want to select just the top 10. So we're going to select top 10 from this particular table. Now, um, each time you do like this kind of query, right? It's important for you to put an alias, like for you to say, okay, as something like as max per maybe table or something, right? You need to put an alias because this is selecting. You're saying select top 10 maximum top 10 maximum fare with their origin from this query. But if you don't do an alias, it's going to throw an error, basically. So you need to specify this subquery as, say, as a table. So, like you're giving that query a table name. And I'm saying, okay, so in a real sense, what you're trying to do is saying select top 10 origin and maximum fare from maximum fare table, of which maximum fare table is this particular subquery in here. So I'm just going to run this and then order by clause. So this, I think this order by should be outside this query. Order by maximum fare. Okay, so while that is running, does anyone have any questions right now? Okay, no questions.
I have a question, please.
Okay.
Yes, I saw the way the 500 assume the training, the average is 500. You enter 500 at the beginning, and then you decide to like a subquery inside another query. You use the try cast, but is the I don't know where the 500. Did we still use the 500 as a standard for the
No, no,
selection
no.
we had? Because I didn't see it in the query statement at all.
Okay, so for this particular query, I didn't use 500 again.
Okay, I was just
I was
wondering.
just okay. That's fine. I just use that as a placeholder while this one was running, right? But we later saw that the average was like $408, right? So and what I was trying to explain there was that normally if you wanted to say um if you wanted to find the itinerary fare greater than a particular value, say 500, you would put 500 in place of this. But because we want to make our query to be dynamic and want to make sure that even if our data set changes, we are getting the right average, right? So they will now have to use the subquery here to select that.
Also, is it possible for you to probably copy, I know initially you put the 500 in front before you added the subquery.
Yes.
Just possible for you to copy that, yes. Copy it from there, then you paste it at the top, then you just add the 500 before the
Yeah.
subquery. So it will, yes, like just duplicate that, then paste that, then replace the one with 500. Exactly.
Yeah.
So that's exactly what it's doing.
Oops. So we have this. Okay. So now we've been able to select the maximum fares together with their origin, or the top 10 actually, the top 10 maximum fares. Um, let's see some questions that I. So something that we could also do is, still on subqueries, right? There are times when you can join a table to itself, and this is called like a correlated query, or you can call it a self join. And the kind of case where you need to do this is, for instance, you're trying to compare a particular value with other values for that same on that same table. That's what I mean. So we want to compare each itinerary fare. So now we know that we found the average itinerary fare here, right? And this is the average. But what if you actually wanted to see how that average price compared with the other prices, like the actual price? So you want to compare itinerary fare to the average, right? To the average value. Now, let's talk about how, first of all, we need to just select the average price, right? Select itinerary fare from the tickets table, right? Of course, we need to cast this, so I'm going to copy all the casts that I've done here, so I don't have to write again, right? And we saw that this was 408. Oh, I didn't put the average there. So we want to find the average, right? So that'll be average. right? Now, but we want to put this particular value to the side, because normally if we just do, let me say, itinerary ID, and you do like, say, the origin, destination, from there, we need to do a group by these three columns. But in this case, what we want to do is actually to still have the price. Let me see. We still want to have this fare to the side. So that query is running. But basically, what we want to try to achieve is we want to have the average itinerary fare on a particular column, and then we want to have the actual value on another column. I want to try and see if this would work. Still running. Okay, so this is the average itinerary fare for this I'm going to run this again. Now I need to put this. I don't think this will run. Yeah, because you always need to add. Also, just to mention, when you're doing your group by, you can also use like 1, 2, 3, 4 for your group by. And this, I mean, in this kind of case, it's kind of useful because you have 4 different columns. And sometimes you don't want to type all this. So you're just going to say group by 1, 2, 3, 4. So it assigns that is not in the outer reference. Okay, I'm referencing this already. That's very fair. I'm not sure why this is doing this. Let me just use the actual column names and let's see. Okay, that works. But what we're going to do now is to do a self join where we are comparing this average cast to itself. So I'm going to say I'm going to have an itinerary fare here. I'm going to write try that's forecast. As decimal. And this is the average price, but we want to make this average fare to be a single column in this particular data set. So what we can now do is say select this is going to be a new column. Right? This is going to be a separate column. Select this from tickets, right? In this case now, we now need to we now need to join these two tables. Like, I mean, join the sorry, 1 minute. Select because we have the reporting carrier, we have the itinerary ID. Okay. Um, I don't think we need the join actually. Trycast is invalid in the select because it is not contained in either the aggregate function. Um, I think this is literally I was trying to do something different, but I don't know what it's because it's contained.
Itinerary fare should be inside the group by as well.
Itinerary fare in the group by. Oh no,
Yes.
sorry. I don't. Oh, I don't need a group by again. Sorry, I don't need a group by here. There's no application. I think that's what I was trying to do something, but oh, you're saying for the previous one, itinerary fare should be in the group by, right? For the previous one I wrote,
Um,
Ctrl Z.
for that, you don't need a group by actually, because you're
Yeah.
only selecting just one column right there.
Yeah. Um, so I'm just going to leave it at this, right? And I was going to talk about something that we call common table expressions. And maybe after this, you can take a break. And if you have questions, you can ask. And so in this case, what we have done is to just write a subquery and then, try to compare that with a different thing or, join tables together or any other thing you want to do. However, I mean, when you begin to write more complex queries, you would see that subqueries can get very messy very easily. Like it will just get very long and very complicated. And so you can use common table expressions to simplify your your query. So for instance, if I was so let me see, if I wanted to say, if I wanted to select places that have round trip to be equals to, let's say 1 or something. So let's say I want to select just itineraries that have their round trip to be equals to 1. Select itinerary ID. Let's say the origin, destination. I'll say number of passengers and itinerary fare, passengers, and then the itinerary fare. Fr from this data set. Right? And we want to see where round trip is equals to 1. Is equals to I think this round trip is a variable character. Let me see if this is gonna work. Okay, it works. So in this case, we know that round trip is currently a character, right? So I just made this to be a string. You can also like try to cast this first to be a decimal or an integer, and then say, so for instance, if I was supposed to cast this to an integer, I would need to cast it to a decimal first. So I'll say like try cast this as a decimal. And then I can now see is equals to 1.0. Am I missing something? Let's see one more bracket there. So really, there are different ways you can do that. Now, these are the round trip in the data sets. People that have like round trips. Now, can I say, okay, out of those people that have that took round trips, how many of them have passengers maybe greater than the let me see. Let me just use a particular value instead of finding the average. I want to say how many of these particular people have passengers greater than 10, right? So what I can now do is say, I'm not going to write a select on this particular statement and say select again all these columns, right? I want to select all these columns again. Okay, I'm going to do Ctrl Z and let me just use the AND statement. I hope this would work. Okay. I think the passengers column so has that same problem. I'm not going to do a try cast on this. Try cast of passengers as decimal. Need to be 10.0. Let's see. Okay, good. So now we've gotten where this is greater than 10, right? But if I wanted to do like where it is greater than the average number of passengers, it means that I actually have to write a subquery for this and say, oh, select. So this instead of 10 now, and I need to use the average value for this and say, oh, select average value of, let's say, just going to put this down. Try passengers greater than select the average try cars of passengers. I'm just going to copy this. So in this case, they're now saying, okay, where are these greater than the average? Okay. An aggregate may not appear in the where clause unless good. So now this is a good use case, right? It's telling us that we can't use an aggregate in the where clause. That's unless it is a subquery containing an having clause. So you probably know this too, that when you are having, if you don't want to use a subquery for your aggregate function, then you have to use like the having function to be able to catch your aggregate functions there. But I mean, this can actually select average. Sorry, there's no from clause here. Sorry, from this. Maybe that's why it's been the error. Okay, that was why I threw the error then. But basically, right, this thing can just begin to get messy and messy and messy. And so with a common table expression, what you can actually do is you're going to use the with function. So they call it common table expressions. Common table. It's called CTE. So if you see CTE anywhere, that's what it means. And it always starts with the with clause. You're always going to start with the with clause, right? So in this case, I would say with CTE as, I mean, and mind you, this can be any name. So I can say with average fare. Just make sure that you have to start with this, with average fare as, then have to select all this average. Right? So now we've been able to where's the string on there? So basically, when you use a common table expression, this now becomes like a temporary table that you can actually query from. And one of the reasons for this is aside from it making your queries more readable, it can also be faster in terms of query run or like running your queries. So because now it's running all those things like one after the other. So no column name address. Yes. So let us continue. This is the table name now in this case, and I'm going to select, for instance, select all from, let me see, from average fare. So this row with this as
Still run it.
huh?
Still go ahead and run it.
No column average fare was specified. I don't know why it's telling me that. Um, with CPU. I'm going to try a more complex query. That works. Okay. I don't know what's wrong here. Yeah. So, anyways, I don't know what's underlining this, but yeah, this is the whole idea of common table expressions, basically. I've been able to say, assign the in a temporary table name to this query such that I'm not able to say from city itself. So you can see that now I'm no longer selecting from the ticket table, but I'm now selecting from this temporary table that I've assigned this query to. It basically means that from this particular query that I have, which I've just filtered on round trips, I can do more aggregations, right? So for instance, um, if I copy this, so we have this table, right? And I'm going to run this. Okay, great. So now I'm now selecting from the city, and I can do more aggregations. I can say, okay, where um you know itinerary fare is greater than 500. I'm going to use the try cast for this. Itinerary fare times decimal. Does someone have a question? The first city. Okay, I'm going to delete this. So right. And I can just do an order by itinerary fare. To be descending and where I'm saying and where the passengers should be greater than, let's say, 5 passengers. Right. So I've been able to order by itinerary fare. I can also order by passengers yet. So let me see. I'm going to do passengers first and then itinerary fare. But I hope you get the point. Basically, what we have done here is to say, now we can see all our select statement is from the city, right? And that way, we are able to do more because what we have done, first of all, is to filter for all the round trips, right? And based on that round trip, we're now getting some new insights, right? Saying this, getting this. And that's basically the function of CT. It helps you simplify your query because if I was to write a subquery for this, what I will do is I'm going to write this first and then write this select statement on top of this query. And then it becomes very messy, like you're not able to read it. But with this now, you have been able to create a temporary table first with a CTE, and now you can select from that CTE and do anything you want to do. So I'm going to stop here, and if you have any questions or you want to go for a break.
Okay, thank you, Justus, for the first session. So we won't be able to take 20 minutes break this time around. So we just take just 10 minutes, and so after 10 minutes, then we can come back for the